2-3, kind of a short one, and it'll be pretty awesome. We're talking about normal distributions. Normal distributions will be a huge part of this class, so today is our first day on it. Normal distributions make this like bell curve right here. You'll hear a bunch of statisticians call it the bell curve. It just kind of looks like one of them old-fashioned bells that people ring, you know. And it has to be symmetric. It's bell-shaped, and it's two main numbers. The mean, oh my God, they're going to start putting this weird symbol right here. It looks like that, you know. It's pronounced mu. It's a Greek letter, just like pi, you know, just like alpha, beta, gamma, all these weird ones. I don't care if you know that that's called mu, but we're going to call it the mean. But you will see him in some of your homework questions, fancy schmancy for the mean. Also, so does that. Remember, x bar means the mean. And then the standard deviation, they use this letter right here for standard deviation. Also, most of the times we do SD, and sometimes it's like that S of X. Easiest thing is if you're not sure what the symbol is, just ask me. I'll be like, they're talking about standard deviation there. So here's how it works. All this stuff we're talking today only works for normal distributed data. Just like I would say the activity we did right there is normal because was it fairly symmetric? Did it make a bell shape? Any skewed data, the stuff we're talking about today, does not follow, right? Only for normal distributions. So here's what we got. The scores of a recent quiz were normally distributed with a mean of 82 and a standard deviation of 2. Do you see they use these cool little symbols right here as well for all that stuff? But they also use the words. They say, like, why don't you just fill out the normal curve in this? Here's an easy way to do it. The mean always goes right here. The mean was 82. And then every one of these tick marks is one standard deviation away from the mean. So if our standard deviation is 2, and the mean is 82, if I go 1 above that, how do you feel about that being 84? Does that make sense? Like I have to add 2 to it in that case. Then what would 2 standard deviations above the mean be? 86, yes. And then 3 standard deviations would go all the way up to 88. You're kind of cool with that scenario right there. But then if you wanted to go below, instead of adding 2, you would have to subtract 2. So 1 standard deviation below the mean would mean that you got an 80 on the test. Then 2 standard deviations would be a 78 on the test. And then 3 standard deviations would be a 76. There are a bunch of homework questions that all they ask you to do is fill out that scale on the bottom. The mean goes in the middle, and then every time you go a tick mark, that increases a standard deviation if you go to the right and decreases as you go to the left. Sound okay? So this question, was pretty easy to do because the numbers were really round. Like 82 is a nice even number and wasn't the standard deviation just up by 2. It's not as easy when things are crazier. So here's like a vocab score test of this really fancy test that they take in the state. You know, like we take the Fast Bridge test. This is like one of theirs. They say, here it is in Gary, Indiana. They have a mean of 6.84 and a standard deviation of 1.55. So like to fill out the scale on this, we have to put the mean in the middle. So you're cool with 6.84 going right there. Right? And then we'd have to add 1.55 to right here. So I could do that in a calculator if I wanted to, but there is an easier way to do it on the applets. If we would go to the applets right here, and if I just kind of went back here, would you guys also go to the applets? You see, we are going to go to this link right here called normal distributions. Anytime we're dealing with a normal curve, this thing's going to save our lives. So if we do this, all you have to do is enter those 2 important pieces of data. The mean on this question, do you see it said 6.84? So let's type 6.84 in there. And then the standard deviation was 1.55. If you hit plot distribution, do you see it creates the scale for us already? So we don't have to add and subtract all those weird little numbers. So when they ask us to fill out the scale, we can just fill out that scale just like they were right here. So let's do that again on this guy. It's in baseball, a player's batting average is the proportion of times they get a hit. Here's what they got. It's a normal distribution. Again, all the stuff we're talking about today only works with normal distributions. If it's got a mean of 0.261 and a standard deviation of this, if I go back to the applets, I can just delete this guy out and change my mean to be 0.261, and then my standard deviation was 0.034. Do you see if I hit plot distribution, it changes all of those numbers. This is your average right here in the middle. 1 standard deviation above the mean, 2 standard deviations of mean, 3 standard deviations above the mean, and then these are below the mean. So pretty basic to fill out the scale on those guys. Does that sound okay? And strong. Then to the back side, there's some cool information about any normal curve. It's called the empirical rule. This will come in strong in the lessons coming up. Save this worksheet. It's got all the answers on it for you. The applet doesn't do this for you. You got to kind of use this, right? So if the distribution is normal, again, that's the big case. Here's what happens. Like 68% of the data falls within 1 standard deviation of the mean. Here's the mean. Would you believe there's going to be 34% to the left of it and 34% to the right of it? If we go back to our activity that we did right here, like it's pretty darn close. Would you believe that like most of our dots are scrunched right there in the middle in that case, right? Like 68% of the dots were pretty darn close to 4.997, which was the mean. So that's pretty cool that 68% of the data is in that zone. And then 95% of the data falls within 2 standard deviations of the mean. So if I highlighted all this stuff pink, if you go 2 to the left and 2 to the right, like 95% of the data is in there. And then darn near 100% of the data is within 3 standard deviations of the mean. Like we call it 99.7. Almost all the data is within 3 standard deviations of the mean if you are normal. Back to our deal right here. To be within 3 standard deviations of this mean right here would be like, okay, 4.997 minus 3 times this. It's like almost all of our data was within that, right? It's just really, really close. So again, only happens with normal distributions. So here's the thing. Let's check this out. One last problem. The heights of U.S. adult men can be modeled by a normal distribution with a mean of 68 and a standard deviation of 2.3. Can you put that in the applet and fill out that scale? I'll pause the video for you real quick, and you can do that. So I went back to this guy, and I put my mean of 68 in and my standard deviation of 2.3 in, and I just had plot distribution. And there they are. You just got to copy them to your worksheets. So I put them all down in that little guy right there. And then here's what the last few questions on the homework are going to ask you. Use the empirical rule. Use the empirical rule. Use the empirical rule. That is fancy schmancy talk for all of these percentages. Like the empirical rule is use these percents. We need to add to our drawing. You will thank me so much if you write this down accurately. So can you see all these cool little percents for each little section right here? They're going to ask us about all these percentiles. Follow my lead right here. Can you extend all of these little standard deviation lines down just a little bit, right? Just use a freehand. You don't need to use a straight or anything, but you see where I added all those red little segments right here? They're at all these standard deviation marks. Just extend them down just a little bit. And then here's what we'll do. They're going to talk about like what percent of the data is all of this. So between here and here, do you see that little pink zone that I have right here? That's pretty, we're just going to read from left to right. That's still 0.15%. Not 15%, just 0.15%. Barely any data is more than 3 standard deviations below the mean. That's where we're at. But here's the real trick. Then they want to know like how much data is right here. I'm going to use orange between there and there. Do you see we have to add those 2 percents together? That's 2.35% between 2 and 3 standard deviations, and then there was also that 0.15. So you have to like add those 2 up. And if you punch those in a calculator, that'd be awesome. Let's add those bad boys up. So I added those guys up, 0.15 and 2.35. Did you get 2.5? That's what's going to happen between there and there. That's how much data there is from all the way to 0% to that second standard deviation below the mean. So what would I have to do here? I'm already at 2.5%. How do I get to this one? What do I have to add to it? 13.5, because what I want to do now is go to this next guy and add this other orange section in. So I got to add all that, which is 2.5 plus 13.5. How much? 16. Sorry, I hit the wrong button right there, but it is 16 is what the correct number is, right? And then here's an easy one. I sometimes like to start with this. What if I highlighted this extra section right here, knowing that that is the average right there, and this is normal? How much of this have I shaded in yellow? What percent have I shaded in yellow? Isn't that half of it right there, which is what percent? 50%. So that's 50% of the data right there, because I was at 16% and I shaded in another 34%. And then if I shade this in, isn't this another 34%? If we were at 50% and added another 34%, where would we be at? 84%. And then just keep going. Right? We add another 13.5%. Like, how much of that is shaded in orange now? That is a 97.5%. Would you believe almost all of that is shaded orange up there in that case? And then if I add a whole nother standard deviation, I would add 2.35 more percent. And would you look at that? Doesn't it darn near look like all of it is shaded in? But it's not. It's not all shaded in. You see there's that little tiny section that's shaded. So if you add 2.35%, you see you got 99.85%. But then if you go even past that, how much would you get when you added that little blue section in all of it? You would have 100% of your data, right? 100% of your data. So these numbers right here will answer a ton of questions, not only on this homework, but coming up on, like, once we quiz it after next week Friday, once we quiz again, it'll answer a bunch. So I hope that you have these guys down, and I hope that you don't lose this worksheet, right? So look how easy it is. It says use the empirical rule to determine the height of all these people. Back to this question, this was like an average U.S. adult height in inches at the 16th percentile. When they say use the empirical rule, it means it's going to land on one of those awesome percents. Do you see this guy right here? Boom, 16%, right? That's the 16th percentile. You got to follow him up and see where is he in relation to the mean. Isn't he below the mean? How many tick marks? Like, here's the mean. How many tick marks did I move to get here? 1 tick mark below. We'll use our graph right here. Isn't 68 the mean? If you go 1 tick mark below, what is the average height of somebody in the 16th percentile? 65.7 inches in that one. 65.7 inches. What is the average height of somebody at the 50th percentile? And they also say use the empirical rule. That means it's going to land on one of those awesome percents. 50 percentile, isn't that right there, baby, right? So you follow it up to see which tick mark you're landing on. Isn't that literally the mean in that case? So you got to go to this guy, and what was the mean? 68, is that what it was? 68 inches. So the last one of the day is, can you find the 84th percentile? It's all by using the empirical rule. Isn't that one of these magic green numbers that are on the screen right here? So it's right here. And isn't that one standard deviation above the mean in that case? So that would be 70.3. Is that what that says? 70.3 inches. This is only good for normal curves, right? And the empirical rule works on those. Next week, we'll learn about what if you were in the 52nd percentile or the 73rd percentile, something that doesn't land nice on the tick marks. But for now, we're using these guys. Let's do some homework. Let me know if you have any questions. Have a good one.